In this video, we are going to look at multiplication properties of exponents. I have an example right here of 3 to the 5th times 3 squared. One way to think of this is that 3 to the 5th is, well, it's 3 times 3 times 3 times 3 times 3. That's 3 to the 5th. And 3 squared is 3 times 3. So what I have here really is 5 3's times 2 more 3's. And if I were to write out 3 times 3 times 3 7 times, sorry, that's a bad 3 at the end. Let's fix that. There we go. Well, what would we think of that as being? This is 3 to the 7th. And that's how multiplication of exponents works. As long as you have the same base, like this 3 is the same as that 3, all you need to do is add your exponents. So 3 to the 5th times 3 squared is the same thing as 3 to the 5 plus 2, which gives us 3 to the 7th. Let's try another example. Here we have m to the 3rd times m to the 8th times n squared. When I'm multiplying with my exponents, I look at the same bases. The m's are the same. The n is not. So, for multiplying purposes, I'm going to have m to the 3 plus 8 times n squared, and nothing's going to happen to the n's exponent. I don't have any other n's. And our final answer is just going to be m to the 11 times n squared. Now, what if I had something like this, though? What if I had x times x to the negative 1 times x to the negative 3 times x to the negative 4. All of my exponents have the same bases. I need to remember that this single x in the front is a x to the 1st, and I can still do the same exact idea with these as I did with my same base exponents over here. This would be x to the 1st plus a negative 1 plus a negative 3 plus a negative 4. And when I add all of that together, I'm going to end up with x to the negative 7. And what happens when we have a negative exponent? Well, we turn it into a fraction, where the base that the negative exponent is attached to moves to the denominator, and the exponent turns from negative to positive. Since there was nothing in front of our x here besides a 1, it becomes 1 over x to the 7th. Now if, let's say I had 2x to the negative 7th, x to the 7th would still go below, but what do you think would be up top? You're right, it would be a 2. So since the 2 is not attached to the exponent, it stays up top. Just the exponent and its base go below. Alright, let's try a little bit different of a topic though with multiplying exponents. What if we have an exponent being raised to a power? Here I have x to the 3rd power being raised to the 2nd power. Well, let's break this down. X to the 3rd to the 2nd is the same thing as x to the 3rd times x to the 3rd. And we know how to handle a problem like this. They have the same bases, so all we have to do is have it be x to the 3 plus 3, which gives us x to the 6th, and that is our answer here. But is there any way that I can do a shortcut, not have to write all this out? Is there any way to take 3 and 2 and make 6? And hopefully you say multiplication. You'd be right. So if you are raising a power to another power, you multiply the exponents. So this would be x to the third times 2, which gives us x to the 6th. And that's a very useful thing to remember. Now, for the last example we're going to do, which can be a little tricky at times, what happens if we have something in front of our variable? What if we have a coefficient in front of the variable? Well, let's take a look. Here we have 4p squared, all raised to the 4th power. Now, as we saw in the previous example, we know that for the p to the 2nd power, it's going to become p to the 2nd times 4, which is ultimately going to give me p to the 8th. But what's going to happen with this 4? That's the big question right now. Well, this 4 is being affected by the exponent on the outside as well. Because if I were to expand out our exponent, we'd have 4p squared times 4p squared times 4p squared times 4p squared. And while I have p squared times p squared times p squared times p squared, which gives me p to the 8th, I also have 4 times 4 times 4 times 4, which is 4 to the 4th. So we have to remember that the 4 inside has an exponent of 1, and then we can still multiply the 1 times the 4. So this becomes 4 to the 1st times 4. Everything gets affected by the exponent on the outside. And ultimately we end up with the answer of 4 to the 4th, p to the 8th. And if you really wanted to, you could simplify down 4 to the 4th, because 4 to the 4th is 256. And then we'd have p to the 8th at the end. Alright, hope you found this video useful. Good luck multiplying your exponents.